So before we get into the back side of this, the table that's on the back, this is our unit circle. I'm told you guys spent some pretty good quality time talking about the unit circle last year. This year, you guys are going to walk out of here at the end of this chapter, you're going to be unit circle experts. Okay. Now, what that means is you're going to have some stuff memorized about the unit circle, but more importantly, you're going to know all these different connections between points on the unit circle, the three key trig functions, how those affect graphs of those trig functions, all kinds of connections. Okay, so being a unit circle pro is not so much about having a bunch of stuff memorized, it's being able to relate one thing to another and pull a lot of different ideas together to solve a problem. Okay, so I'm going to introduce it. We're going to start building out our library of connections today. We'll probably have a bunch of stuff I'm going to throw at you. Some of it's going to stick, some of it's not, but that's okay. We just kind of want to get our feet wet with this whole unit circle thing, okay? So first of all, what makes this thing the unit circle is its radius. The radius of this circle is 1. So a unit circle will always have a radius of 1. And if the radius is 1 in your circle, then it allows us to deal with some, it's just a very convenient thing for us to deal with trig functions for our different angles. There is a thing called standard position. We'll be talking a lot more about this on Friday, but I want to introduce it today. In standard position, we call the positive x-axis, we call that an angle of 0. And then as we rotate counterclockwise around the unit circle, then our angles increase. So if I start here, I'm going to skip over a couple of these points, and I go up to here. What's my angle up here? How far around the circle have I gone? I start at 0, going this way, we get to 90. Keep going around, gets us to 180. Another 90 after that. We're at 270. One more 90 degrees gets us back full circle 360 degrees. Let's write these angles in radians as well. Let's practice thinking in radians. So nice thing about 0 is 0 doesn't matter what your units are. 0 is 0. 90, do you remember what 90 is in radians? Pi over 2. (180), we've used this one so many times, we should all be right on top of that. 180 is pi. Now, can I get you guys to look up here? This is going to allow us to skip some stuff and move a little more quickly on Friday. And we've talked about this a little bit before. When we're coming up with these radians, sometimes what we're doing is counting. So if I start at 0 and I count up to here, this is 1 pi over 2. And then I rotate another 90 degrees. Now I'm at 2 pi over 2. Now, would I ever write 2 pi over 2? You would cancel the 2's and it's just pi, right? But it is 2 pi over 2, agreed? So here's 1 pi over 2, 2 pi over 2. If I go another 90, now I'm at 3 pi over 2. And then another 90 gets me to 4 pi over 2, but we never write 4 pi over 2. We would write 2 pi. All right, let's do our 45-degree angles next. So find your 45-degree angle. So we're starting back at 0. We're going to rotate 45 degrees and go ahead and label that 45. And then let's kind of keep going around the circle and hit all of those multiples of 45. Then we'll come back and do radians. So there's 45. Another 45 gets us to 90. Another 45 past 90 would be 135. When we get to 180, we go another 45 past 180 gets us to 225. And then we get to 270, and then another 45 past 270 gets us to 315. And then another 45, and we're back at 360. Do you guys remember how many radians 45 degrees is? That one is pi over 4. So let's count our way around the circle. This time we're counting in pi over 4s. All right, so I start right here. I go 0, and then I go 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay. Next up, I want to do 60. So start back at 0, rotate 60 around. That's going to get you to this point here. Go ahead and label that 60. And let's count in 60s around here. So there's 60, plus another 60 would be 120. Plus another 60 is 180. Plus another 60 is 240. Plus another 60 is 300. And then another 60 gets us back to 360. So let's count our 60s. 60 degrees is pi over 3. So we'll count around 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and 6 pi over 3 would be 2 pi. All right, we only have 4 more points to label. This is a 30-degree angle to get to that point. This one is 30 degrees shy of 180, so that would be 150. Here we're 30 degrees past 180, so that would be 30 plus 180 is 210. And our last blank one, we're 30 degrees short of 360, so that's 330. When we're dealing in multiples of 30, we'll be counting in pi over 6s. 30 degrees is pi over 6. So we'll count every 30 degrees. So basically, we're going to hit everything except for these center ones with the 5s at the end. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. 12 pi over 6 would be 2 pi. All right, so these are all the angles. If you're going to do our memorization quiz, these will be all the angles you'll be responsible for. All the multiples of 30 and 45 around the triangle. The first quiz that will be at the end of next week is going to be, I give you degrees, you give me radians. So make some flashcards, start practicing. You can earn some bonus points. Okay, any questions there? All right. We are a little short on time because of our drill today, so I need you guys to pay close attention to me here, okay? The backside of this sheet is not critically important for you to have done, okay? So when I put you into partners or a group of 3, only one of you is going to fill this out. Please do not waste your time filling this out if you are not the person in the group who's going to fill it out. If you walk out of here without the backside of this filled out, that is okay. Okay, we're not turning this in. These numbers are not important in their own right. What I want you and your group to see is there's some connections you're going to see with the numbers. Okay, so let me repeat that. Do not waste your time copying down someone else's table. Only one person in the group needs to fill this sheet out. Okay, what I'm going to ask you to do, first of all, go ahead and change this to 100th. Ask you to get with a partner, and I would like you to fill out the coordinates column first. I want you to work as quickly as you can. I'm going to walk you through an example. The reason both people are going to have one of these is the person who's filling out the table is going to have their sheet that side up. The other person is going to have their sheet this side up. Okay? So let me flip this around so I've got all my angles on here still. So I'm going to we'll just do the first 2 columns together. So I want you to think of this angle, this point at an angle of 0 here. Okay, I'm doing my top row. Think of this as a point. It is a point. And tell me, what are the coordinates of this point right here? What's its x-coordinate? 1. We didn't need to estimate it. It is exactly 1. What's its y-coordinate? 0. Okay, do not fill out the rest of the table yet. I need you to fill out this entire column first before you start on the rest of it. All right, let's do 30 together. I want you to look at this point right here at 30 degrees and estimate for me the x-coordinate to the nearest 100th. So would you agree it's somewhere between 0.8 and 0.9? So what do you think? 0.86, 0.87, 0.88, 0.86? Okay. 0.86, comma. What does it look like the y-coordinate of that point is? 0.5. It's right on the 0.5, yeah. 0.5. Okay. As quickly as you can, you and your partner, I want you to fill out this column. When you get this column done, I want you, and while you're working on this, guys, there are some things that will make this easier for you. If you recognize that there's symmetry going on here, like, aren't these 2 points going to have the exact same x and y coordinates, except this one's going to have a negative x, where this one will have a positive x, right? But the y coordinates are going to be the same, aren't they? So look for some of those patterns to make this more efficient for you. Once this column's completely filled out, then I want you to grab a calculator, okay? And I want you to fill out these 3 columns. The way you're going to do that is, for example, for this first row, I'm going to type in cosine 0, write that down. Then I'm going to type in sine 0, write that down. And then I'm going to type in tan 0 and write that down. So most of these are going to be decimals, so round them off to 1 decimal place, please, okay? But do this column first as quickly as you can, okay? On your marks, get set, go. Let me know if you've got questions. I do not want anybody working together, so if you're sitting by yourself, move and find a partner. You could spin around and work in a group of 3 right there, or there we go, that'll work. Come on up and join this group up here. Join in with one of the other groups here. Bring your calculator with you. To finish up. So pay attention up here. I'm going to show you a little trick on the calculator involving the table. So here's what I'd like you to do. Go ahead and first of all, make sure you're in degree mode on your calculator. We should all be in there, yeah, or else you're going to have to go back and redo the whole table. But what I'm going to show you is going to make that a lot easier. We want to go to the table settings. The table settings is the second function for the window. So hit second window and go into your table settings. And could you please change your table start to 0, delta table 1, and then this one you will probably need to change. Change the independent to ask. Second window to get to the table settings. and set the table settings as I have them up here. Okay, we got it? All right, we're not going to graph anything, but we're going to go into our y equals because the y equals also controls the table. And go ahead and set yourself up like I got this here. For y1, do cosine, y2, do sine, y3, do tangent. Of x. Each of them is going to be of x. And don't bother hitting the graph button because we're not doing graphing today, and our calculator is not set up to graph these things properly right now anyways. All right, I'm going to pause until everybody's got those in. I'll know that you're caught up to me when you're looking up at the screen waiting for my next instruction. Okay, we are ready to go. So now I'm going to go to my table, hit second table. Now most of your tables are going to be blank. That's good. For those of you who, like me, have some stuff in your table already, you need to get rid of it. So the way you get rid of it is you use your cursor, move it up to the top X, and just start hitting delete until everything is deleted. So if your table is not blank already, please get rid of whatever's in there. All right, are we good to go? We all got blank tables? All right, so if I wanted to fill out this table right here, I can choose, when I'm in ask mode, it's basically telling me I can choose the X values that I want for my table. I'm going to type in 0 and hit enter. Then I'm going to type in 30 and hit enter. And I'm going to type in 45 and I'm going to hit enter. And I'm going to type in 60 and hit enter. And then I'm going to stop. And what do you notice about those numbers that are popping up on your screen? Aren't those the exact same things that were in your table? Now, those of you who've got kind of the old school calculator like me, you're not seeing all 3 columns. You're only seeing 2. But if you use your arrow key to move the cursor over, you can get to the 3rd column also. So if you are not done filling out your table, please just type in the ones that you need here and then just fill them in straight off of the screen. This keeps you from having to type in sine of some angle like 30 different times and then go back and repeat for cosine. Okay, it's a real time saver. Go ahead and finish that up. My question to you, once you get your table complete, is to find the connections in the table. We're going to discuss that in about 3 minutes. I need you guys to finish up quickly. I'm sorry to keep rushing you. They stole some time from us today. Okay, folks, pause those side conversations. Thank you so much for working quickly through that. Thank you for discussing the connections with your group. So there are 3 really huge connections that I want to make sure we make, and then there's a whole bunch more going on here as well. The big connections are the connections between the columns. Guys, can you pause for just a second? I love that you're still talking about it, but we're running short on time here. Can you tell me how the cosine column connects back to the coordinates of those points? The cosine column is exactly equal to the x coordinate of each of the points, right? So you've got an x coordinate and a y coordinate, and your x coordinate matches up with the cosine value. Maybe not exactly, but they are close and they are actually equal to one another. How does the sine connect back to the coordinates of the points? It is the y coordinates of the point. And then this one's a little bit trickier, but how does tangent connect back to the coordinates of the point? Y divided by x. I'm looking at this one. Does that work here? 0 divided by -1 is 0. I'm going to try and find, here's a 1. 0.7 divided by 0.71. That's going to be pretty close to 1, isn't it? What happened at 90? 1 divided by 0 is undefined, right? So you nailed it. You nailed it. So the y coordinate divided by the x coordinate is the tangent. So I'm going to go back to this page. Could you guys go back to your unit circle with me, please? And I want to write down our key observations. On the unit circle, any point on the unit circle is going to have an x and a y coordinate. and the x-coordinate is always going to equal the cosine of the angle, and the y-coordinate is always going to equal the sine of the angle. So x goes with cosines, y goes with sine. This is one of those deep, deep connections that we're going to use over and over and over again. Who's in physics right now or has taken physics before? You guys are already familiar with this, right? When you were doing your vector stuff, x goes with the cosine, y goes with the sine. The other big thing that we found is that if we take the x and the y values, that the tangent ends up being equal to x over y. I'm sorry, y over x, wasn't it? And we're going to use an alternate version of this a lot. Tangent theta equals, if it's y over x, then tangent turns out to be equal to sine over cosine, because that's what y is, and that's what x is. So tangent is equal to sine over cosine. I want to make a couple other small connections, and this is going to be, remember I said I'm going to throw some stuff at you, and some of it's going to stick, and some of it's not going to. Everything past this point, it doesn't matter if it sticks now, because we'll catch it later, okay? But I just want to throw it out there for right now, okay? So I want to think about this. I want you to think about this angle of 30 degrees. What does the cosine have to do with this angle? I would say the cosine is going to give you the x-coordinate of this point, right? And what does the sine have to do with that angle? The sine is going to give you the y-coordinate of this point. What is the tangent going to tell us about for this spoke right here? What is the tangent going to tell us? It would be, someone said it. It's the slope, isn't it? It's, if you think about it, it's the rise over run that would get you from this point out to here, right? Rise over run, it's the y over the x. So tangent is related to the slope of each of these points. Now, why is it important that we do the unit circle when we're doing this? The reason we do a unit circle is because it forces our hypotenuse to be 1. So I want to show you why the y is the sine. If I asked you to do, I'm going to put this on a separate piece so this doesn't get too muddy. Let's start with cosine. If I asked you to find the cosine of theta, you would look at this and say, oh, it's about 0.86 over 1, right? Because the hypotenuse is 1. And 0.86 is your x-coordinate. So it doesn't matter what the hypotenuse, the reason the hypotenuse is 1 is to make the cosine match up with x. If the hypotenuse had been 2, then this wouldn't be the x-coordinate anymore. Does that make sense? What else did I want you to see? That's probably the biggest stuff. So this is going to take a little bit off of our plate for tomorrow. Big ideas today. As we rotate around the unit circle, we start at 0 here. Positive angles go this way. We'll talk about how we can do negative angles going the opposite direction tomorrow. But the really big thing from today is that the points on the unit circle are connected to the cosine and sine. X with cosine, Y with sine. Are we good? You guys are awesome. I'll put the assignment up. I'm going to tell you that this is probably the shortest assignment that you're going to